Okay, so the next we have here is manometer. Manometer is one of the, I think I'll say one of the popular type of pressure measuring devices. I'll be giving us a breakdown of the different types of manometers. But first, I want us to note that manometers are used to measure high pressure and negative pressures. First thing you must know is this: manometers are used for measuring comparatively high pressures and negative pressures. Okay, I will explain that as we continue. Now, that's the first thing you must note for measuring high pressures and negative pressure. That's one. Two, manometers can be called, they are called what? They are called liquid gauge. They are called what? Liquid gauge, because everything there is about liquid. All right? They are called what? Liquid what? Gauge. Now, we have at least three types of manometers. We have three types of manometer. The first one is called the simple manometer. The simple manometer. We have what we call the differential manometer. Differential manometer. Then the third one is called the inverted differential manometer. Inverted differential manometer. All right, so these are the three types of manometers. All right, so what you are seeing on your screen is a simple manometer. We call it the U-tube manometer. Please, let's look at this very closely, because I'll be showing us the other one, which is differential manometer. So please try and spot the design of the different types of what? Manometer, because in your exams you might be asked to compare and contrast between the simple manometer and the differential manometer. So please, what should be here is simple manometer. All right, now this manometer is very easy. As you can see on your left, it is attached to a gauge pressure. So what you are seeing here, point A is the gauge pressure, while one end is open to the atmosphere. I hope we are seeing this. One end is attached to a gauge pressure, while the other end is open to the atmosphere. That's one. Two, we have two parts. We have the left limb. Yes, it's called the left limb. This is called the left limb. And this is called the what? The right limb. Okay, that's one. Number two, at point B and C, look at this, guys. Point B and C is called the datum level. It's called the datum level. I will explain that very soon to us. Now, the datum level is the point where the pressure at point B is equal to what? The pressure at point C. So I can say that the pressure at point B is equal to the pressure at point C. Okay, that is this point. So when you are solving questions on manometer, always look for the datum level. All right, that datum level are always equal. Okay, so the datum level on the left limb must be equal to the what? Datum level on the what? On the right what? Limb. All right, good. Step 2. Step 2. Now, if you look at the left limb, here we have the gauge pressure. So the gauge pressure is right here. Now, what you are seeing in the tube is mercury. You have mercury in this tube, and what is in the gauge pressure is water. Okay? Now, when water or when the gauge pressure applies pressure in the tube, okay, the water, it pushes the mercury towards the what? The right limb. Okay? Now, at this point here, at this point should be what we call the pressure in the atmosphere. All right? But in this case, it is equal to what? To 0. Because it could not prevent the mercury from rising to this level. Or I can say because the pressure in the gauge is more than the what? The atmospheric pressure. In some cases, the pressure in the atmosphere is strong enough that it can push the mercury towards the left limb. But in this case, the gauge pressure is greater than the atmospheric pressure. So therefore, we call it what? We call it what? 0. That's 2. 3. There is no specific equation for solving manometer. Please take note. There is no equation. You have to look at the diagram to get your equation. And what I'm showing us now is how we can get the equation. Step 1, you have to check your datum level. All right? The pressure in the level is equal to what? The pressure on the left limb is equal to the pressure on the what? Right limb. Now, let's look at the pressure on the left limb. Number 1, I have the pressure in the gauge. As you can see, look at this, guys. Number 1, I have the pressure in the gauge. So I can say, number 1, on the left limb, I have the pressure. I have the pressure in the gauge, okay? Plus, also I have pressure. That is, I have pressure due to the depth of the fluid. As you can see right here, which is H1, I have pressure due to the depth of the fluid. That is the pressure on the left limb. Now on the right limb, I have what? 2 pressure there. I have the pressure in the atmosphere, which is 0. As you can see, is 0. Also, I have what? Pressure due to what? The depth of the what? Fluid. So I can say I have what? Pressure due to depth of the mercury. That's mercury now, okay? While on my left is pressure depth of the what? Of the fluid, of the what? Water, okay? Because the pressure on this gauge is water, okay? So here is how we can derive equations for pressure in a manometer. From these, we can solve for the pressure in the gauge. So therefore, I can say that the pressure in the gauge is given as PA What is this? Okay. All right. So therefore I can say that the formula is what? Pressure in the gauge, which is PA, plus pressure due to the depth of the water is what? Is density times gravity times the depth, which is H1. As you can see, is H1 equal to the pressure due to the what? Depth of the mercury, which is what? Density times G times what? H2, because the height of the mercury level here to the datum level is H2. So this is the formula we can use to solve questions in this form. Also, I will show us another type of diagram. Look at this here. Look at this here. As you can see here, the diagram is different. In this case, the atmospheric pressure here is greater than the pressure in the atmosphere. As you can see, it pushes the mercury towards the right. But in this case, the gauge pressure is greater than the atmospheric pressure, so it pushes the mercury towards the left, towards the right. But in this diagram, the atmospheric pressure pushes the mercury towards the left, so the formula will be different now. Okay, the formula will be different. But first, step one, note that B and C is your datum level, which means that the pressure at B is equal to what? The pressure at C. Okay, so the pressure at B is equal to the pressure at C. So from this, we can also derive our equation again, looking at the diagram. On the left, I have the gauge pressure, that's one. I have the pressure due to the what? Height of the water, H1. Also, I have the pressure due to the what? Height of the mercury. So I can say, therefore, my formula becomes, the first one is the gauge pressure, which is the gauge pressure plus, I have H1 there. Remember, for H1 is the water, so I can say is the pressure due to depth of water, plus also I have the what? The mercury, which is H2, so I can say pressure due to depth of mercury equal to what? To my right hand side, which is just what? The atmospheric pressure, which is the what? The atmospheric pressure. So therefore, I can say that my equation becomes gauge pressure, which is PA, plus the pressure due to the what? Depth of water, which is density times G times H1, plus the pressure due to what? The depth of mercury, which is what? H2, which is what? Density times gravity times H2, equal to my right hand side, which is just my atmospheric pressure, which is what? P atmosphere. So guys, with these formulas, we can solve questions depending on the type of system or design we are given. Please, there is no fixed formulas for manometer. You have to be able to interpret the left limb and the right limb. That means you can equate the left limb to the right limb to get your equation before you can solve your questions. And please, as you can see in this question, you can see that your what is this? Okay. So you can see that from the question that the pressure in the atmosphere is not strong. So it's 0 because the gauge pressure is what? Is greater than the atmospheric pressure. Please, anytime you see that the mercury is going higher on the left, it means that the atmospheric pressure is negligible. It's not strong enough. So we call it what? 0. All right, let's go now. Step 1, I look at my what? Datum level. So I can say that pressure at B is equal to pressure at point C. All right. Okay, good. Step 2. Let me look at my left limb. Okay, my left limb, I have two pressures. I have the gauge pressure, which is PA. Okay, plus I have the height here, which is the pressure due to the depth of water, because it's water, so I can call it my PGH1. All right, remember that it's for water, so I call it PW. All right, for water is equal to, on my right I have just one pressure, because in the atmosphere the pressure is 0, so I ignore this. So I have just the pressure due to what? The depth of mercury. So I can say density of mercury, gravity times H2. Now in the question it says calculate the gauge pressure. So I am to calculate what? My gauge PA. So therefore I can say PA is equal to this PM GH2. This move over to this side, this come to my left, become minus density of water, gravity, H1. So with this we can solve the question. So therefore I will log in my data. So the density of mercury is 13.6 times 10 to the 3 times my gravity is 9.81 times my H2 is 0.55 minus density of water is 1000 times gravity 9.81 times my H1 is 0.35. All right, so 13.6 times 9.81 times 0.55 gives us 73378.8 minus 1000 times 9.81 times 0.35 gives us 3433.5. So when we subtract this, our answer should be 69945.3 Pascal. If you don't mind, you can decide to leave it in kilopascal. It becomes 1, 2, 3. That will give us 70 kilopascal. So that is our final answer. The differential manometer is used to measure pressure from two different points. For example, point A and point B. Okay, that means that we can use differential manometer to measure the difference of pressures between 2 points in a pipe. I repeat that. Differential manometer is used to measure the difference of pressures between 2 points in a pipe or in two different pipes. Now look at this. Now as you can see right here, you have the mercury here. Now the mercury is the heavy liquid, okay, while the fluid in A and B is water. Okay, so the fluid Q is mercury. Now again, point C and D is our datum level. Point C and D is our datum level. That means that I can say that the pressure at C is equal to the pressure at D. So from this we can derive the equation. What I'm seeing here is that the pressure at A is greater than at B, so it's pushing the mercury towards the what? The right limb. So that means that I have on my left limb, okay, let's start with the left limb, okay, left limb. On my left limb, all right, so on my left limb, number one, I have the gauge pressure, which is I have the gauge pressure at B, all right, plus I have the pressure due to the what? Depth of the water. So I have pressure due to the depth of fluid P. So also that's it on my left limb. Now for my right limb, again I have pressure gauge at B. Okay, I have pressure gauge at B, that's one, plus number two, I have pressure due to the what? Depth of the fluid P. I have pressure due to the depth of fluid P, plus again I have what? Pressure due to what? The depth of the what? Mercury, which is fluid Q. I have pressure due to the depth of fluid Q. So we have to understand the design of the manometer so that we can get our equation. So that is the formula. So I can write out the formula in equation form. So therefore I can say that I have gauge pressure at A, which is PA, plus the pressure due to what? The fluid depth at P, that should be what? Density P, GH equal to the pressure gauge at B, which is PB, plus the pressure due to the what? Depth of fluid P, so which is density of the fluid P, gravity times H2, plus the pressure what? Due to the what? Depth of fluid Q, which is density of fluid Q times gravity times H1. So this is an equation we can use to solve questions that relates to differential manometer, but we have to be able to interpret the design. Very, very important. So question one, we know that pressure at point C is equal to the pressure at point D. Okay, let's go now. Now at my left limb, I have the gauge pressure, which is PA, plus the pressure of the depth of the fluid, which is what? The rho of the fluid is what? And it's water. So it's water. Look at it. It's water. So rho W times G times H. Okay. Equal to. Now my right hand side, number one, I have the gauge pressure B, which is PB, plus number one, the pressure of the water. Look at it here. Is this point? So it's rho of water times G. Now, guys, to get the height of our depth of water is H2 minus H1. So it's H2 minus H1. To get the height, the depth of the water is H2 minus H1. All right. Then plus the depth of the mercury is the rho m mercury times G times H1. With this formula, we can solve the question. So remember, in this question, we are not given what? The density of what? Water. But I know that specific gravity W is equal to what? Rho times G. Okay, so therefore I can change this to specific what? Weight. So therefore I can say the PA plus the specific weight of the water, okay, times H, all right, equal to the PB plus, I can change this to what? The weight of water. So specific weights of water, H2 minus H1. Then I can change this to what? The plus the what? The specific weights of mercury times H1. And also, I told us before this slide that the specific weights of mercury is equal to what? Gravity times specific weight of water. Please guys, you can look at your notes from last week. I told us that the specific weight of mercury is equal to what? Specific gravity, which is S, times specific weight of water. So therefore, my formula becomes the pressure at point A plus the weight of water times H equal to the pressure at point B plus the weight of water times H2 minus H1 plus the weight of mercury becomes what? Specific gravity times the weight of water times H1. So we have to remember these formulas. So now we can log in the data to get our answer. So my pressure at point A, remember we have to find what? The difference in pressure. Okay, so therefore I can say that my pressure at point A minus pressure at point B, we just transpose now, is equal to this, the weight of water, H2 minus H1 plus the specific gravity, S, times the weight of water times H, then minus this, minus the weight of water, is H1, water, times the H. All right, so therefore we can log in our values. The weight of water is 9.81 times 10 to the 3, open brackets, my H2 is 0.75, minus H1 is 0.5 plus my gravity is what? Is 13.6 times the weight of water is 9.81 times 10 to the 3 times H1 is 0.5 minus weight of water is 9.81 times 10 to the 3 times H. Our H is 1.5. All right, so now we can calculate now. So 9.81 times 10 to the 3, open bracket, 0.75 minus 0.5, that should give us 245.25. That gives us 245 52.5 plus 13.6 times 9.81 times 0.5 gives us 666,708 minus 9.81 times 1.5 gives us 14715. 14715. All right. So when you put this in your calculator, you should get 5445.5 watts Pascal. That's our final answer. You can convert to kilopascal, becomes what? 1, 2, 3. So that is what? That is 54.4 kilopascal. So that is our final answer. So this is your practice question. So try and do it and submit to this email address as soon as possible.